Hello, welcome back. So this is an example problem. I'm just going to start. I'm not going to actually finish, but if you were given a problem of finding the resultant displacement of walking 15 meters south and then 25 meters west, with what you have right now, you would pick a scale and say one decimeter, or let's say 1 centimeter equals 5 meters. So I would make this a 3 centimeter arrow due south. Then I would add to that a 5 centimeter arrow due west. I would add that together, put them tip to tail, and then draw them out, then measure my resultant and use my scale that 1 centimeter equals 5 meters, and then I'd get my answer, and I'd use a protractor to measure the angle. But there is a better way of doing it in most cases that we're going to be dealing with it. So if I had 11 kilometers north and I added to that 11 kilometers east, okay, notice I formed a triangle here, and that is a specific type of triangle, a right triangle, which means we can use a tool that we already have in our toolbox, and that's Pythagorean's theorem. So a squared plus b squared equals c squared, right? So if we wanted to figure out the resultant, I wouldn't have to get my ruler out and protractor out and all that stuff. I would just use 11 squared plus 11 squared equals my r, my resultant squared, and get the resultant equal 15.6 kilometers in this case would be the correct answer. And as far as an angle goes, instead of getting a protractor out and measuring angles, we're going to use sine, cosine, and tangent. I'm not going to spend much time reviewing those, but you will need to be able to use sine, cosine, and tangent. So that's kind of the big deal here. In finding the answer to this one here, the sine equals the opposite over the hypotenuse. Sorry, opposite over hypotenuse. And so they found that the sine equals 45 degrees. So we'll work a quick example. What's the resultant velocity if the velocity is the result of 35 meters per second south and 12 meters per second due east? And so I drew my 12 meter per second east vector, and then I added to that my 35 meter per second south vector. And then we're going to use Pythagorean's theorem. 12 squared plus 35 squared equals r squared, where r gives me 37 meters per second here. And then to find the angle here, theta, we use the tangent function, opposite over adjacent, SOHCAHTOA. So tangent of theta equals 35 over 12, and we take the inverse tangent of both sides, and we get 71 degrees. So here is another problem that we're going to use sine, cosine, tangent, and Pythagorean's theorem for. So you're driving 35 meters per second south. You turn with a constant acceleration for 12 seconds, and your velocity is 9 meters per second east. What was the average acceleration during this period? So hint, how would you find delta V? Well, so this is my V1 is 13 meters per second. My V2 is 9 meters per second. And what we want to do is find delta V. Well, delta V equals V2 minus V1. So V2 is 9 meters per second east, and we want to subtract from that 13 meters per second south. Remember, when we subtract vectors, all we do is we flip them and then add them. So I flipped my 13 meters per second up, and then I'm adding them by putting them tip to tail, and we get the resultant equals 15.8 meters per second. We use the tangent function, and we got 55 degrees. You could use sine or cosine and use the 15.8, and that's fine too. I just chose to use the tangent function. I forgot to actually find the acceleration on this. Once I know the delta V, we divide that by time, which was 12 seconds, and that would be the answer to our problem. So let's say we had another problem, 31 kilometers per east, and we want to add to that 15 kilometers due northeast, okay? And we want to figure out the resultant. Can I use Pythagorean's theorem on this triangle? The answer is no. Okay, it's got to be a right triangle. It is not the same. The answer is not the same. It's not a right triangle. I had a student argue with this with me. He said you could use Pythagorean's theorem anytime. It's not the case. They've got to be right triangles, which is going to be convenient for us because we're going to be dealing a lot with right triangles. Again, so there's three basic ways that you can approach these vectors. You can use the graphical approach, which means that you're going to get out a ruler and a protractor and use a scale. That's very versatile, but it's going to have a lot of error. You can use the law of cosines, but that only works with two vectors. And then you can do addition by vector resolution. This is the preferred method, the one that I'm going to spend the most time on, and we'll explain what that is. So I could use the law of the law of cosines. Is that the law of cosines? The law of cosines to find the resultant, and then I could use trig to find the angle. Law of sines to find the angle. But there's another way that I'd like you to learn that's a little bit better. So what we've been doing is adding two vectors that have been to find the resultant. So we add x and y and we get the resultant. You can also take a single vector, in this case a. We can also take one vector that's at an angle and we can break it up into x and y components. This is called vector resolution. So we've got an x and a sub x and an a sub y. So rather than adding multiple vectors and getting the resultant in one vector, you can take a one vector and you can break it apart into its component vectors, its x and y component vectors. And this is very useful. It's also very easy. So since we broke up a into ax and ay, it is the same as the addition of those two. Okay. Make sure when you do this that you put arrowheads on your vectors. So we've got a vector A and we're going to break it apart into its component vectors. So make sure you put arrowheads on those. Notice that this vector points down and to the left. So you've got a down vector and a left vector. You do not have an up vector and a right vector because that's not the way that vector is headed. So this is basically the opposite of addition. This is called vector resolution. So it's just simple sine, cosine, tangent kind of stuff. So if we hike 2.6 kilometers and we go 23 degrees north of east, what is your north-south, which would be your y component? And what is your east-west displacement, which would be your x component? So what we do is we don't have to draw it to scale. We don't have to get a protractor out. All we have to do is kind of sketch it out. So we've got 23 degrees north of east. So this is east, and this is 23 degrees north of that. 2.6 kilometers is asking for the x and the y component. So my y component, the sine of 23 equals opposite over hypotenuse. So ay equals 1. And then find our x component, that's cosine of 23 equals adjacent over hypotenuse, and that equals 2.4. So this is just vector resolution is just sine cosine, basically. So it's no big deal. Now that is, we've added vectors that were perpendicular very easily. Vectors that are not perpendicular require a little bit more work. We had to use the law of cosines, but we can also use a different method, and this is the one that I'm more interested in you guys learning. So yeah, we can add these vectors. We cannot use Pythagorean's theorem, but this is how we're going to add them. You're going to take the vectors and you're going to break them apart into components. So A, you're going to break apart into an AY and an AX. It's just simple sine cosine, no big deal. And then B, you're going to break apart into its components. Okay, X and Y, sine cosine, no big deal. And then what you're going to do is you're going to add the x's together, because I can just add x's, just like math. 1 plus 2, or 1 plus 2 equals 3. Okay. And I can add the y's. All right. And then notice that when I do that and I form a new triangle, Now I've got a right triangle with these two. I've got an x component and a y component. I can use Pythagorean's theorem because I now have a right triangle. So basically the key part here is you take your vectors, you break them up into x and y components, you add your x's together, you add your y's together, you get an x total and a y total, and then you're going to use Pythagorean's theorem and sine, cosine, tangent to find your result that way. This is the preferred method of doing it. It's a little bit more work. So these are the basic steps, but we'll go through those. So here we've got three vectors, and we're going to add them. Now they are tail to tail, but what we're going to do is, in order to add them, we're going to break them apart into their components, and then we're going to add the components. We'll be essentially putting them tip to tail that way. So if this freaks you out, don't worry about it. We'll be adding them tip to tail by mathematically. So the first thing you do is you take your vectors and you break them apart into the x and y components. So here we're doing a plus b plus c. So I found my ax is 3.1 and I found my ay is 11.6. The b vector only has an x component, 15, so its y component is 0 because it doesn't have anything in the up and down. And then the c vector, now that's pointed down and to the left. So when I find my x component, it's going to be left. So that's why I made that negative. Okay? And my y component, okay, that's down. So that's why I made that negative. And now to find the x total and y total, or x total and y total, I add my x's, my ax, my bx, and my cx. I got 8.7 meters. Okay, and then we do the same thing for the y, my ay, my by, which is 0, and my cy, which is negative. And we get minus 9.4. Now what I'm going to do is I'm going to redraw this triangle with my x total and my y total. So my x is 8.7, okay, to the right. And see, we're putting these vectors tip to tail, so I told you we'd be doing it that way. And then my y total, that's negative, so I put it down. I went ahead and drew it down, so minus 9.4. It's negative. And then we use Pythagorean's theorem to figure out the r, which is a 12.8, and we use inverse tangent to find theta, which is 47. Now I could have done that with 100 vectors. It just would take more time. So I can use addition by vector resolution for any number of vectors, whereas law of cosines you can only use with 2 vectors. So now on the next example up here, it said what's a plus b minus c. Here's what you do. Since what you do is you flip the vector that you're subtracting. So instead of subtracting 9.4, I flip it and I add 9.4. Now I flip the c vector and I get a new number. And when I find my y total, I flip the cy vector. Instead of being negative 21, I flip it to positive 21. And then I do the same thing here, where I redraw the triangle with my x. Here's 27.4 and my y is 32.6. I use trig to find my answer. Okay, and that's where we're going to stop.